All right, let's get into it. Today, we're talking about the two big models in computer networking, OSI and TCP/IP. You can think of it as a tale of two things. One is this perfect, super detailed blueprint, and the other is the actual, powerful machine that got built. I mean, have you ever really stopped to think about that? You click a link, and poof, a web page from the other side of the planet just appears. It feels like magic, right? Well, it's not. It's all thanks to a very clever, very organized rulebook that lets all our devices talk to each other. And we're going to unpack how that rulebook came to be. You know, for any two computers to have a conversation, they've got to be on the same page. They need a shared language, a process they both agree on. And that's exactly what these network models are. They're the standard framework that makes sure a message from an iPhone in Tokyo can be perfectly understood by a server in Toronto. So, first up, let's look at the theoretical ideal. It's called the OSI model, which stands for Open Systems Interconnection. You can think of this as the gold standard blueprint, designed by a major standards organization to be the perfect, comprehensive guide for how any network should work. It's this beautiful, 7-layer masterpiece of theory. Okay, let's do a quick tour of these layers, from top to bottom. We start up at layer 7, the application layer. This is the part you actually see and touch, your web browser, your email app. Right under that is layer 6, presentation. This guy is the translator, handling stuff like encryption and making sure data is in a format your device can use. Then we've got layer 5, session. It's like the conversation manager, opening a line, keeping it open while you communicate, and closing it when you're done. Layer 4 is transport, and it's super important. It makes sure all your data gets to its destination reliably and in the right order. Next up, layer 3, the network layer. This is the GPS for your data, using IP addresses to figure out the best path across the internet. Almost there. Layer 2 is the data link layer. This handles the local neighborhood, using MAC addresses to get the data to the next hop. And finally, we hit layer 1, the physical layer. We're talking the actual hardware, the cables, the radio signals, the raw ones and zeros flying around. So if the OSI model is that perfect blueprint, what's the actual engine powering the internet we use every day? Well, that would be the TCP/IP model. This is the framework that was actually built, the one that got the job done. The TCP/IP model is way more streamlined, just 4 layers. Its application layer at the top is a real workhorse. It basically combines the jobs of the top 3 OSI layers all into one. The transport layer is pretty much a direct counterpart to OSI's layer 4, handling that end-to-end communication. The internet layer lines up with the OSI network layer, managing the route your data takes. And finally, the network access layer just merges the bottom 2 OSI layers, dealing with all the physical hardware and transmission stuff. So there you have it, the 7-layer theory versus the 4-layer reality. Let's put them side by side and really see how they stack up. And this is the most crucial takeaway. The OSI model is a fantastic conceptual tool. It describes every possible step in networking in incredible detail. The TCP/IP model, though, it's the practical, let's just make it work version. It's literally theory versus practice. This right here is the aha moment. When you map them out, it all clicks. You can see clear as day how the top 3 OSI layers, application, presentation, and session, get bundled into that single application layer in TCP/IP. And at the bottom, the data link and physical layers get combined into the network access layer. The middle layers, transport and network, they line up almost perfectly. This little table sums it all up, doesn't it? 7 layers versus 4, a conceptual model versus a practical one, developed by an international standards organization versus DARPA, the U.S. Defense Department's research agency. And the big one. One is used for teaching and as a reference, while the other is the actual backbone of the internet today. So I know what you might be thinking. Okay, if we only really use TCP/IP, why did we just spend all that time learning about the OSI model? That's a great question, and it's the most important takeaway here. The reason we still care about the OSI model is because it's an incredible tool for learning and for troubleshooting. Because it's so detailed, when something breaks on a network, engineers often think in terms of the OSI layers to diagnose what's wrong. They'll ask, is it a physical cable issue? That's a layer 1 problem. Or is it a routing issue? That's layer 3. The OSI model gives them this super granular map to find exactly where the problem is hiding. And hey, if you ever need to remember those 7 layers, whether it's for a test or just to impress your friends, here's a classic little trick. Just remember the phrase, all people seem to need data processing. The first letter of each word gives you a layer, starting with application at the top and going all the way down to physical. Pretty handy. So, to wrap this all up in a neat little bow, the OSI model, is that beautiful, detailed 7-layer blueprint. The TCP/IP model is the simplified 4-layer engine that took those brilliant concepts and actually built the internet with them. One is the perfect what if, and the other is the practical what is. And that leaves us with a fascinating question to think about. The internet was built on the practical simplicity of TCP/IP, but as we rocket into a future of the Internet of Things, AI, and global hyperconnectivity, you have to wonder, is that 4-layer model going to be enough? Or might we need to look back at that old, detailed 7-layer blueprint for some fresh inspiration? Something to chew on.